This is going to be a brief description of how we take the visible light on the planet Earth and do our best to render it accurately in our digital images. And this is the same problem that photography technologists had since the dawn of photography, how to render color accurately. Here's a representation of the full electromagnetic spectrum, from short wavelengths like cosmic rays to the longer wavelengths of our broadcast bands. In here is the tiny little portion that's what we call visible light, what we can see. And you probably remember from all your years of school the old Roy G. Biv gag, which is red, orange, yellow, green, blue, indigo, violet, which describes the visible light. Outside of the visible light on the short wavelengths we have ultraviolet. On the long wavelengths we have infrared. Okay, so now our job is to accurately render these colors that are out on the planet Earth on our digital image file. So let's see how that works. We're going to talk about the additive primaries. The primaries that we deal with are red and green and blue. These are the additive primaries because when you add them together you create white. Now this is white because these are fully saturated colors. If these were somewhere below the 255 range, this would and equal, this would be a gray. Gray is an equal amount of red, green, and blue. All right. Now you'll see a number of interesting things here. When red and green overlap, they create yellow. Red and blue create magenta. Blue and green create cyan. The other thing we can tell from this is that if we look at opposites, red and cyan are opposites, green and magenta are opposites, and blue and yellow are opposites. This means in our image, if we're adding blue, we're simultaneously removing yellow. Likewise for the other opposites. And this becomes important when we're figuring out how to retouch an image. To remember that adding red is the same as subtracting cyan. So that's how the additive primaries work together. So what we are going to end up having is, with our images, we'll have three channels: red, green, and blue. Each of these channels will be rendered, in our 8-bit images at least, with a possibility of 256 levels of gray going from black to white in each of these three channels. And I'll talk more about that in the next talk.